All right, let's look at how to solve the system using the matrix functions in your calculator. If you did your flip notes, you've already got your steps written down, and the first thing it said at the top of the page was to make sure that your columns are lined up. So we want to look and make sure that everything lines up with the same variables. This one doesn't, it's not ready to go. We want to leave the top one as it is, it's already in standard form. We're used to looking at equations that look like that, but I need to get this second one in order. The 3x is already on the left side of the equal sign, which is where we want it, so we're going to leave that alone. But this negative 5y is in the wrong place, so when we move that over, it becomes positive 5y. 3x is positive, so we'll put a plus sign there. We're going to leave the 9 where it is. Now everything's lined up and ready to go. So the first thing it says to do is to write or generate a coefficient matrix. So we're just going to take all of the numbers straight from where they are, and we're going to write them down in a matrix A. And that'll be 7, 4, 10, 5, 3, 9. And at this point, I'm going to get my calculator out and go find the matrix menu, which is right here over the x to the negative 1 button. It says matrix, it's in blue, so second matrix. We're going to edit, and it's already got A highlighted, number 1, so press enter. And you need to enter the dimensions. It's always rows by columns. So if I look right here, I've got 2 rows, press enter, by 3 columns, 1, 2, 3. Now, if you mess that up, if you come up here and you hit 3, 2, and the shape doesn't match, it's not a big deal, you can always go back and change it. 2, 3. You have to hit enter after each one or it doesn't know you're finished entering information. A matrix is just a chart. It's a representation of what information is in the equation. That's all it is. So I'm going to pull my coefficients, 7, and when I hit enter, it moves to the next one, 4, 10, 5, 3, 9, and enter. Once I have all my values in, I have to quit out, and again, quit, it's blue over the mode button, so second, and quit takes me back out to the edge. What we're going to do now is we're going to use the RREF feature, and that stands for reduced row echelon form. And what that does is it undoes all the operations so that I have a matrix in the form 1, 0, some number, 0, 1, some number, which I read as literally 1x is equal to the number, and 1y is equal to some other number. This is in the x, y, x, y, so it stays in the same format as our original one, but when we've worked backwards through all those values, it'll give us our answer. So we come back using the instructions that you pulled from the flip assignment. We're going to go to second matrix. We're going to do some math to our matrix, and when we scroll down, our ref, hit enter, and then it wants to know which matrix am I going to reduce row echelon form. So I go back to matrix and tell it A by hitting enter, and then it shows me this form we were looking at. There's my diagonal ones, and this says that x equals -6 and y equals 13. Ta-da! So the systems are easy enough to solve by graphing or using substitution or any of the other methods we've looked at before. When this is really handy is when I have an equation with more than just the 2 variables we're used to looking at. So let's look at example 2 with 3 variables. 3x plus 3y minus z equals 19. 5x plus 4y minus 2z equals 28. 2x plus 2y minus z equals 12. We still set up our coefficient matrix just like we did in the last one. So my matrix A equals, pull just the coefficients, 3, 5, 2, 3, 4, 2. Coefficient on this z, be careful, is -1, -2, -1, and then 19, 28, 12. When we go back to the calculator, second matrix, edit. The dimensions have changed. I've got more, I have 3 rows, and now 1, 2, 3, 4 columns. So we're going to enter. And these dashes over here let you know there's more information. It doesn't have the closure. 5, 4, -2, 28. 2, 2, -1, 12. Got it all entered. Just like last time, we quit out of there. We go back to matrix, math, all the way down to number 8, or letter B. Again, go back, tell it matrix A, hit enter, and there I still have, so it says 1x equals 4, 1y is 3, and 1z is +2. Now we're going to write that as an ordered triple. So x equals 4, y equals 3, z equals 2. I can write that, my -6, 13 would be an ordered pair, -6, 13. Since there's 3, we call it an ordered triple, and we're just going to write 4, 3, 2. Anytime I see the 3 lined up like that, I know it represents x, y, z. All right.